In this video, we will explore Genesis Visualizer to create a video recording. Let's reopen the Hello example from the installation tutorial. We activate the Genesis CPU environment. And open VS Code in the Hello example directory. Previously, we imported and initialized Genesis CPU, created the scene and enabled the viewer, loaded a single plane object and a Franca arm into the scene, and finally, built the scene and started simulating. Now, we will edit the interactive viewer options. In this example, we set the resolution of the viewer to 1280 by 960 pixels. The position of the viewer's camera relative to the origin. The look at position of the camera, that is, the coordinates where to point the camera to. The field of view, FOV, of the camera, in degrees. And the frames per second, FPS, that the viewer will be captured at. We then proceed to configure visualization-related properties that are independent of the viewer or camera. For example, whether to visualize the world frame or not. The length of the world frame's axis, in meters. Whether to visualize the frames for each rigid link. Whether to render the cameras added to the scene. Whether to render reflection on the world plane. And the color of the scene's ambient light. Within the Genesis scene, we can specify the renderer to be used by the camera, which we will add afterwards. This does not affect the interactive viewer, which always uses rasterizer. You can check Genesis official documentation for many other viewer and visualization options. The documentation also details the photorealistic ray tracing rendering backend, which we will cover in a separate tutorial. We will keep the already added plane and Franca arm for this example. Let's manually add a camera object to the scene. Notice that cameras are not connected to the interactive viewer. Within the Scene Add Camera command, we can specify this camera's properties. In this example, we set the resolution to 1280 by 960 pixels. We specify the camera's position relative to the origin. And the look at position. The field of view, FOV, in degrees. And the GUI option, to specify whether we want each camera to create an OpenCV window to dynamically display the rendered image. Once we build the scene, we can render images using the camera. By default, only RGB is rendered. We can optionally turn on rendering depth, segmentation mask, and surface normals. We can now start recording on the camera. All the RGB images rendered by camera render will be stored and saved to a video file when the camera stops recording. We import NumPy to use its sine and cosine functions to create a nice movement for our camera. We will rotate the camera 360 degrees around the robot arm as it falls freely on the floor. Within the for loop, we set the camera position dynamically, but keeping the height fixed at 2.5 meters. The look at position remains unchanged. For each step, after setting the camera position, we call camera render to render the RGB images. Finally, we call camera stop recording so that all RGB images stored so far will be saved to a video. In this example, we specify the parameter saved to file name equal to video.mp4 so that video.mp4 is saved in the current directory. We also set the number of frames per second (FPS) parameter. The script is all set and ready to run. Confirm that Genesis CPU is the active interpreter, and run the script. Genesis will be initialized, and the simulation will start. After a few seconds, the interactive viewer will open and the settings applied to the viewer and visualization options will be in place. The simulation may take a few minutes to complete. Notice that at the end of the simulation, the video will be saved as video.mp4. Then Genesis will cache the compiled kernels and exit. The recording of the camera is now stored and we can open the video file. By following these steps, you have successfully modified the interactive viewer options and added a camera object to record and store a video of this simple Genesis simulation.